Thank you, Ryan, and welcome everyone. I hope you're inside safe and warm. It's been a rough couple of days, and I hope you have some good plans for Monday for the eclipse. I unfortunately will be at City Hall, but my kids will be watching it and excited and with bated breath. But we're here tonight because we're all very concerned, and we know that we have a very engaged community around the air quality of our neighborhood. We've done a number of studies over the years, over successive governments and over decades, around the Clarkson airshed. And we know how incredibly important it is that in our taxed airshed that we're doing everything we can to reduce emissions, whether through vehicle traffic, transportation, or our industrial partners within the South Down employment area. So really want to thank everyone who's been so engaged on this issue for being here today, but also for engaging with Ash Grove over the last several months as well. I did want to say that there are a lot here that we are going to be learning and trying to understand. So, I'm not an engineer myself, but been trying the best I could to understand some of the challenges that are happening here. And I'm hoping that the presentation you'll see today, and as long as the Q&A period, will clarify and clear up any concerns or confusion that you might have. But ultimately, I think we know that this is a step that's being approved by the Provincial Ministry of the Environment in Ontario, and that they're the ultimate authority that is going to approve site-specific standards here, which Ash Grove has been working with to develop over the last several years, and that I felt that it was important for me to reflect the concerns of our neighbors to the province, and was happily able to put together a motion with the support of some of our residents, like Julie Desjardins, as well as Councillor Mahoney, who have a number of residents as well. And we passed that motion just a couple of days ago at council, where we wanted to make sure that the province was doing their due diligence in terms of these standards, and keeping to really an improved timeline, and making sure we do check-ins. But as I understand, Ash Grove will be talking about that today. And that's the other thing I wanted to say, is that this is not, the first meeting that we had an opportunity to go and drop into the hotel was an opportunity for some members to engage, some residents to engage with Ash Grove. And that obviously was required. This meeting is not required of them. So I do want to thank Ash Grove for taking the time, and for Rahul and your team for really being as open as you have been with me in my office, to take part in this meeting, and to really want to engage with the residents and their concerns, to clear up any of the issues, and to really understand what you're trying to do and how you're going to mitigate the emissions over time. So I think it's worth sort of acknowledging that, because I think it's important to say that you have been willing partners with the city, with me, and I hope that whatever happens with the province, that continues moving forward, as you have been an important member of the community for decades. We just celebrated your one of your anniversaries last summer at a fantastic event that brought people from the community. So I expect that relationship will continue, and that we will continue having opportunities to engage with you, either through my office or directly through the Community Liaison Committee. So with that, again, want to thank everyone for coming on today, and hoping that you'll get a lot out of this. Again, we're going to put it on the website, and just wanted to make sure everybody was able to come together and hear all the same things from Ash Grove. So with that, I'll turn it back to Ryan and Ash Grove. Thank you, everyone.
Thank you, Counselor. With that, I would like to bring on the main event and pass it over to Bruno and the team from Ash Grove.
Yeah, we're going to go through the boardroom at the facility, where we have a number of people from the operational team to have some introductions as well for the rest of the community members. And we really wanted to thank the counselor and your team for the opportunity to have this discussion today, and everybody that's on the call that's giving us the feedback that we continue to incorporate into our plans and work for the site-specific standard in parallel with the ministry. So we really appreciate that opportunity as well. So I'll turn it to the team in the boardroom for the introductions, and then I'll introduce myself as well. I'm Bruno Morgado. I'm the optimization manager here at the facility. been engaged in working with the ministry on the development of these site-specific standards. And we'll go through that and some of the concerns as you mentioned earlier. So with that.
Okay, so thank you very much and good night. Thank you very much, Councillor, for the opportunity to discuss this today. As Bruno mentioned, we would like to engage with the community. We want to make sure that we hear the feedback and most important, answer those questions that maybe are not answered. I hope this session helps to do that today. My name is Raul Morales. I am the general manager of the plant. And I'm really nice to see everyone here and actively engage participation.
Naz Hayat, Ash Grove Cement.
Luis Fuentes, plant manager in Susaga Cement.
Okay, I'm Fernando Valencia. I'm the VP Manufacturing for the East Region.
I'm Stephanie McKenzie. I'm the environmental manager.
My name is Tina Elliott. I'm the environmental advisor.
And with that, I will just pass the hand over to Bruno. He will take us through the presentation, and then after that, we will just have some Q&A as Ryan mentioned before in the introduction. And thank you very much again for your time.
Thank you, and hopefully everybody can see my screen now.
Yes.
Presentation, perfect. Yeah, so again, thank you everybody for being able to join us tonight. We wanted to work through a lot of the feedback that we had as a follow-up to the December 6th meeting that we had with our community members. This is something that's very important to us, and we want to make sure that everybody understands that we're treating this very seriously with all the seriousness that it deserves. We're going to be covering some of the introduction to who Ash Grove is and how we came about with the current corporate structure, and then also talk a little bit about how cement is made, and then work through the process that we've been working with through the ministry. One of the main themes is from 2018 to 2023, the development of the site-specific standard application. So we'll work through some of that information with the group, and then we'll go through the action plan items and talk about how they link up with the process things that we talk about at the start of the presentation. And then we'll close and go to questions as was mentioned by Ryan. So. Yeah, so the plant has been in operation for a long time. We started operation in 1956. And in 2015, the plant has been purchased by CRH. And the plant has continued to modernize and develop over the course of all these many years and grow with the community, part of the core and foundation of our performance. This is something that CRH is very fond of and wants to make sure that everybody understands that this is something that CRH has in their sustainability statement. So CRH has the corporate portal. It's an Irish company, and they purchased this, like I said, in 2015. And so they have the corporate portal with the sustainability, and then they also have the aggressive targets for CO2 for 2030 and 2050. While those are not the things that we're focusing on for tonight's discussion, all the environmental parameters are very important to CRH and the operation of all the sites globally. As a follow-up to 2015, when CRH took us over, subsequent to that, they purchased Ash Grove Cement in the United States. Ash Grove is the branding currently for the facility, and this is something that we've become, the name has changed. So some of the community members may have historical views of the facility, but currently we just want to make sure that we give the clear distinction that we are CRH and Ash Grove, and environmental sustainability topics are very much fundamental to our business. And then can also see on the right some of the key parameters about the location of the facility, how many people we employ, how long we've been in operation, and how many products we produce and so on. One of the things that's really empowering for us, we feel, in the company here at the plant is being able to engage with our corporate community partners. And the community engagement goes through the Compass Group, the Peregrine Falcon Foundation, Arma House, Friends of the Museums of Mississauga. We've also worked to build new relationships with the McMaster University for trying to get engineering students into the program to work here at the facility eventually, as well as the recent certification with the Wildlife Habitat Council. So these are all really important endeavors for us. And then, as the councillor mentioned at the top of the presentation, is that we were able to host for the first time since 2019 our open house. The open house was publicized throughout the community, trying to bring people into the facility and have a view of what are we doing here and how we're continually trying to improve the performance of the facility and our environmental performance as well. One of the most fond things for me during that event was, in addition to being able to raise 125 pounds of food for the Compass Group, was having those community partners also having displays during the event and having them being able to connect with the community members and neighbors at our facility. And then the other thing as well, there was tours available for community members to go around the facility and see how the cement is made today in the modern era. We're not the same company that we were historically. And the image for me in the middle is a very powerful one. It connects a lot to the children and trying to understand that hopefully they can see the binder company that we want to be in the future. And we are endeavoring to have the best performance and start driving to be that modern company and have the environmental sustainability initiatives at the core and foundation of our business. So it was good to be able to see the children looking out at the different parts of the process during the bus stops. I was a tour guide during the open house, and I thought that was one of the most rewarding aspects in addition to the donations that we were able to make to the Compass Food Bank. As I said, the environmental performance is something that we've been working on for quite a long time at the facility. And we see the CO2 benchmark here that we're now starting to endeavor on. From 2010 to 2022, we've reduced by 9% the CO2, and there's going to be a lot more activities and actions that we really want to share with the community. We recognize this is not the core of what we're talking about today. We're updating our website as well, and that'll be available with a link when it gets published to the members of this call. We'll ask Ryan and his team to help share that website link when it's ready for implementation, which we expect to happen in the next coming days. We also show that over the last, and this was also presented in the December 6th meeting, that since 2003 to 2023, the plant has reduced SO2 by a measure of 68% on the total output of the facility. And then likewise for NOx, we've reduced by about 18%. So these are because we are an ISO registered company. We've been an ISO company since 2004 at this site. And we continue to maintain those practices and look for opportunities to improve our environmental performance. And that's something that's fundamental to everything we do here at the site. Now I'm going to turn a little bit to the cement process at a very high level and describe that for a lot of the members, understanding that maybe people aren't familiar with the cement manufacturing process and what it involves and entails. So the first step is we take limestone from our quarry. This comes to us from a barge from Ogden Point, which is about 2 hours outside of the plant location. That material gets ground to a fineness similar to flour or talcum powder that people may be more familiar with how fine that material is. This is done under the watch of very sophisticated equipment that continually monitors and adjusts the chemistry of the materials coming in. And about 90% of the material coming to the site for production is from that quarry. The quarry has a high amount of pyritic sulfur. This is one of the challenges for SO2 specifically, but this is something we feel very strongly about that we can work on and make significant improvements to the operation to reduce the SO2 input as a starting point, using these sophisticated tools to help us with the chemistry, to make sure we have continual operation, because our operation is a continual basis. It's not a batch process. It operates continually, and this would help us reduce our emissions, reduce our energy intensity. There's a lot of drivers from operation perspective that we want to make sure that we keep the plant operating as consistently as possible. And it all starts with that quarry material and the watchful eye of that sophisticated equipment to make sure the chemistry is as consistent as possible coming into the process. After that material has been ground and processed, we feed it to a preheater tower and a clinker in a kiln. And here you can see the image at the bottom that it's really a magical process from my perspective. I think this is something that is really not understood, that we take this limestone that's been ground, And with the chemistry and the temperature that we put into the process, we're able to produce clinker material. And this clinker is something that is now reactive and helps form the basis of the cement product that we're going to be manufacturing in the upcoming steps. The clinker produced is monitored continuously by the trained plant staff with XRF and XRD equipment. That's the most modern equipment to be able to monitor the production of the clinker, but also to help us reduce our energy intensity and the chemistry and the quality of our finished good. So this is, again, utilization of the most sophisticated tools that are available to the modern cement operators to make the material as sustainably as possible. One of the other elements that we didn't touch on too much is during that raw meal process, we were able to also incorporate other materials such as shale from local construction projects. That shale, for last year as an example, we were able to reuse 95,000 tons of shale into our process. That becomes part of our finished good. From a chemistry perspective, it helps us with our process in the clinker manufacturing. And it also helps divert this 95,000 tons of shale that would historically have gone to landfill from the excavations for condominium jobs or other construction activities locally in the neighborhood. So this is something that also happens with the different fuels that we would have, that combustion products becoming part of the ash would become part of the finished good, which is another big benefit of the clinker manufacturing process. Finally, because we have all these sophisticated tools monitoring our process and continual adjustment, we're able to substitute some of the clinker in the final cement to reduce the emissive intensity of the CO2 and still have a product that the finished construction companies have no quality objections with. You can see here there's two different cements side by side. They have different colors because of the different proportions of materials that we add to the cements. And again, this is carefully monitored throughout the entire process because we want to make sure that we have consistent operation throughout. So having covered the cement manufacturing process, I'm going to be going through on the right of the image there. You can see we have the kind of a timeline of what we've been going through since 2018, because this was one of the most frequently asked questions that was provided following the December 6th meeting, both in writing as well as phone and so on. So we thought it was important for taking this second opportunity to have this community engagement, to provide additional detail of what were the things that we're working with in parallel and concert with the ministry to prepare our site-specific application and have the action plan ready for implementation at the completion of that and when the ministry approves the application eventually, whenever that may be. So in 2018, the Ministry of Environment, Conservation and Parks announced that the SO2 limit would change from 690 microgram per meter cube to 100 microgram per meter cube. This was done with a 5-year work and phase-in period. And when doing the assessment at that time, the plant was in a much simpler compliance perspective from a modeling approach. The tool was being used was AirMod, and this was something that the ministry normally uses for assessments of emissions from facilities such as ours. However, in 2019, and as a consequence of that as well, also want to point out that in 2018, when we were looking at those operation of the facility, we would have been in compliance with the new incoming standard of the 100 microgram per meter cube with AirMod in operation. However, in 2021, the ministry requested the plant to undergo a Screen 3 assessment. This assessment was completed at the request of the ministry and in working with some of our consultants to prepare that information. This resulted in a new model being used for our facility to govern the compliance, which was CalPUF. We'll speak quite a bit about the development of CalPUF because it's a much more sophisticated software to be able to capture what are some of the things that we need to consider. The rationale or reasoning for making this change, you can see here the location of the plant. We're on the Lake Ontario, as you can see, and our stack is within 1 kilometer of the lake. And this new software is much more powerful. It has a lot more computing power. And with that, it can better predict some of the meteorological events that could take place. such as shoreline fumigation. And what that means in a more simple way is that the cooling effect of the gases coming off of the air coming across the lake and moving inwards, it would have the potential to condense or densify some of the gases coming from the stack and bring it to a lower level in a much faster way than what would have been predictable. This is not something that AirMod can capture. So this is why the ministry requested the Screen 3 assessment. The Screen 3 assessment as an outcome said that we had to change our modeling approach, and the ministry asked us to consider CalPUF for this determination. CalPUF is the most sophisticated tool to do this kind of assessment. And so we started working with our consultant team to develop the CalPUF modeling, and we'll talk about that a little bit more in the subsequent slide. So this is the context of what we were working on at the time and how we were developing all these different touch points. So CalPUF is a modeling software. As I mentioned, it's much more sophisticated than the AirMod. Previously, AirMod would have been something that you can install on an ordinary laptop and be able to run the process from start to finish within a week or so with somebody that had an understanding of how to use that software appropriately. However, CalPUF is something that the ministry would have to give approval for. So we had to apply to the ministry to be able to use the software after the Screen 3 assessment was completed. And this isn't something that we can just choose to do on our own. We had to request this to the ministry, and they had to approve being able to use CalPUF for the modeling through our Section 7 notice. And CalPUF, again, being much more sophisticated, takes many months to develop with somebody that's knowledgeable in the tool and has experience with setting it up. And then each model run takes a much longer period of time to deliver. So in doing the CalPUF preparation, we had to consider the worst case weather conditions. So this was looking with the ministry. We've been working on this with the ministry since 2021 in terms of looking for what are the correct meteorological stations to be considered for the CalPUF file. And then also looking at what are the grids. And the grid for the purposes of the site-specific standard is a 36 kilometer by 36 kilometer grid. All the information in terms of elevations and buildings of significance and whatnot had to be put into that system as well. And then we, in parallel, worked on the max emission scenario. The max emission scenario was an interesting one because we have a voluntary program for CEMs, or continuous emission monitoring systems. Those continuous emission monitoring systems are looking at the stack gases and giving us some understanding of how we're performing for the different constituents of the stack gases. Again, this was a voluntary program. And so because of that, the ministry needed to come in and audit that system, which was done as well as part of this process, and then validating the data that was being outputted from these tools to be able to give the final information to go into the CalPUF software and basically take a look at the worst hour of operation from a meteorological perspective, as well as from the max emission number from our CEMs. So those two came together in a bit of a theoretical exercise to make the most conservative approach and output of the CalPUF model. And that's what we're using to do our application for the site-specific standard. And again, this took many months. We were 15 to 18 months in the development of the CalPUF model and what this all meant with all these different steps and things that needed to be configured and validated with the ministry's assistance. So in parallel to that, because the CalPUF takes quite a bit of time to run the models, in parallel, we developed an analytical tool to help us understand the outputs of the CalPUF model in a simpler way that we can use to govern the actions and operation of the facility and try and understand what's driving some of these numbers and how we can start thinking about making a continual improvement without having to wait for this process to finish. We're motivated to continue to reduce our emissions. This is something that we feel very passionate about. And so we understand that CalPUF takes time to do each model run, and it would be normally done on an annual basis in the future when compliance is going that way. but we wanted to have some way to have an understanding or estimation of how the process is operating in the current day. And this is something with that analytical tool that we've developed that we can generate a lot of data that helps us understand what's going on in the process and where we have opportunities to make significant improvements in the current day operation. So this is something we've already started working on and incorporating into our day-to-day operational context. So in parallel to wrapping up the CalPUF model configuration, we started to work on that max emission scenario, as I mentioned earlier, and the validation of the max emission scenario with the ministry. We also started working on the technology benchmark report. The technology benchmark report is something that we worked on with many subject matter experts, both at the consulting companies that were supporting us through this, as well as our internal. We lean very heavily on the corporate subject matter experts that are available to us from the US, as well as from global support organizations. So we had probably over 20 people working actively on this file to see what are the best technologies to consider for our application and what are the potentials for each of those to help us develop the action plan that's realistic and credible, because this is something that's very important to us. We want to make sure that we deliver an action plan that everybody would be understanding is something that we can achieve and not have to have a conversation later about why did we try and have something that might be a bit more aggressive, but might not be really hitting all the marks, because the devil is always in the details. So subsequent to that, what does it all mean? At the end of the day, the facility is the same, the operation and the emissions, as I stated at the beginning, we've been reducing for a long time. The modeling definitely casts a difference on the operation in terms of what the output looks like. However, we recognize that CalPUF is the way that we need to look at our operation and model our compliance in the future. And this is why we've submitted the site-specific standard using CalPUF for our operation. Going back to AirMod, just in the modern day, does not make sense for us in our operation. So with that, I'm going to be going over into the action plan. And with the action plan, you can see that we have a number of different steps we've been reducing for a long period of time. And then depending on which one we're looking at, either SO2 or NOx, because of the different mechanisms that are related to the process and the operation of the facility, and because of that tool that we were able to develop to understand the process, we have slightly different action plans developed for each of those, and some elements that will be communal and impacting both emission contaminants. So the first item on our action plan that we're going to delve into a little bit more detail is for SO2 emissions. SO2 emissions reductions will be accomplished, as we say here, with looking at different sorbent technology. Currently, we're permitted for a lime injection system, which we operate in the current day. Using the analytical tool, we're looking at ways of how we can improve our lime injection in the current context, as well as trying to understand some additional ways in which we can improve our lime injection in the future if the ministry agrees to these items as part of our action plan. We're also considering these different sorbents. There's a successful company called Solvay that has Trona. Trona is a different sorbent, and that sorbent is able to have better efficiency of removing SO2 from the stack gases. So that's something we want to explore. We're currently not permitted for this material at the site, but we're working with the ministry on how we can conduct some trials and eventually see if this is something that we can use as part of our action plan. Relating back to the quarry, as I mentioned at the top of this discussion, the quarry has a pyritic sulfur input that is significant, and using those sophisticated tools in the laboratory, we're able to measure the pyritic sulfur and modify the quarry operation already in the current day. This is something we've done in the most recent years to help reduce our SO2 emission from our site. And it's something that we will continue to do as we look to source additional materials for the operation of the facility and further reduce the input of SO2 into the process. We know what these materials are. We don't want to say it in the public forum, but we are actively looking at trying to do some trials. Again, if the action plan is agreed upon by the ministry and we can move forward with these new materials, because again, we're not permitted for some of them. So that's for SO2. I lost my mouse, sorry. Next is NOx. NOx emissions is a big part of that is from the combustion process. And from the combustion process, we're going to be looking at the operational elements as well, using that analytical method and analytical tool that we've developed. We're also going to use the current selective non-catalytic reduction system. So this is using ammonia. Ammonia is something that we can inject into our process in the kiln process to be able to have the reaction to knock out the NOx and consume ammonia as part of the process. So again, we're using that regression tool to see how can we improve the operation of that system and improve how our performances of that as well. A smaller item on the NOx is that we have a small diesel generator for the portable crushing plant. Down the line, we're going to look to electrify that system so like that we can have an improvement on the NOx from the facility as well. But this is a smaller action item for us that's in our plan. Looking at items that are common to both the SO2 and NOx, we have action plan items to improve the operational SOPs, again, relying on that analytical tool that we've developed to help reduce our current state. And this, again, is something that we've started last year, and we're actively following with the operation of the plant on a regular basis. Additionally, we're looking to install a couple of community ambient monitoring programs. Although our compliance will be done and measured with the tool of CalPUF, we also understand from the community that they want to have an understanding of what's the actual measured concentration of these items in the actual field and in the community. So that's why, as part of our action plan, we've included have a couple of ambient monitoring stations that we're going to work with the ministry. We've started having conversations with the ministry on these already to try and understand where are the most suitable locations to have the additional ambient monitoring stations implemented. We already operate a couple of community monitoring stations as part of the CASIA program historically, but these would be additional to that. And finally, there would be the discharge of the emissions through the main stack. There would be some efficiencies gained by putting all the gases into the main stack and help with the dispersion effects as well. So that would be something that would be, if you look at the facility on the left here, we have quite a complicated installation, as I mentioned. Through all the years and projects to modernize our facility, we have 4 stacks to consider for all our action plans. Combining the 4 stacks and trying to have a functional way to get the ducting across, there's a lot of additional upgrades that would need to be required to be installed at the same time to make that upgrade. So this is going to require some time for the engineering design and then implementation and testing, which leads us back to overall what we see as our action plan. This would be one of the major steps to help reduce both the SO2 and NOx. And then after the implementation of that, we would see that there would be a couple of years. We recognize that all it takes is 1 hour of operation to knock the compliance out. And that's why we wanted to make sure we had a credible plan where we have, although the request is made for 10 years, we would be looking in 6 or 7 years to have that major modification done. And then afterwards, it would just be a fine tuning. And that's why you see the leveling out on the right side of each of the graphics that are here. So it's a big step for us, but the company, again, is very serious about the continued performance environmentally, sustaining our operation with the community partners and making sure that everybody understands that we've been reducing for quite a period of time. We're very engaged in this space, and we have a lot of big plans and a lot of big ideas to continue to reduce our emissions, not only for SO2 and NOx, but again, also for CO2. And again, we'll give those links in the follow-up to this meeting when that website is live. If anybody from the community wants to be able to reach out to us, we have our Environment Mississauga web email address. This is the best way to get in contact with us, as we would be able to answer those, and those would be logged. There's also a phone number, but the phone number is something that gets logged as well, and we would be able to follow up with the people on the next business day. We're looking at that system and something that we're trying to understand going forward as well.